Hello everyone. Today we're going to be looking at specific examples, specific use case for finance, for tax, for accounting. The use case for fine-tuning LLM, fine-tuning or tweaking or customizing your AI. So we have a basic large language model, and we'll make it do things differently. We'll make it do things our way, uh, as per as per the policy, the tax, travel and expense policy that we have. So in finance and tax teams, they do spend a huge amount of time reviewing the travel and expense claims, checking meals against per day allowances, making sure hotels don't exceed nightly caps, or that flights follow the company's travel class rules and policies. So in effect, our use case is centered and revolves around expenses policies. What if we could train a AI model to read the policy text itself and then automatically judge claims against it? That's exactly what we're building here, a policy-aware AI assistant. And we're doing this using large language model, a very simple large language model, not very advanced, not as advanced as something like ChatGPT would have, or Grok, or the one from Google. So, first step is us using the base model. So we start with a pre-trained language model. In this case, we're going to be using Quan. It's only 1.5 billion 1.5 billion parameters model. So normally the basic models are 7 to 9 billion. So this one is just a model that's capable of understanding English. So think of it as a general purpose AI that has some understanding of English and can reason with basic ability and with text, but doesn't yet know our company's travel and expense rules. That's the key point here. So the travel and expense policy information here that we're going to be providing, it will be a proprietary information. So each company has its secret policies, set of systems that it's using, set of parameters, and obviously no ChatGPT has ever been trained on this. So we're going to fine tune it. We're going to feed some additional information to this model, and we're going to tweak its weights. So here is an example of how this works. So if these purple points here that you're seeing on this picture, they would represent coefficient and weights. They would be the ones that hold kind of the information within the model, that store it, store information, store the facts, and we're going to change them in order to incorporate our special policy. Right, so to train it, we need examples. And we generate synthetic but realistic company policies for different locations. So we have here in Python, we're using obviously Google Colab, and here we have a set of policies. So New York, California, London. I'm highlighting that is Berlin. Yeah, so just several countries, and we're specifying policies. So meals allowance per day, it's different for every city. Lodging cap, so that's how much they can claim in terms of hotel per day. Ground daily cap, and a bunch of rules in terms of no alcohol and etc. Various other rules. So we just created a set of basic rules. Then here we're creating the text of the policy that will be fed to the to our AI large language model, and we're going to create a bunch of these cases, bunch of these examples, so the model actually has so many examples that at some point it starts learning what it means. And for every policy, for every example, we'll say, okay, so there's a meal receipt that's been submitted, let's say for California policy. That's how much they claim they've spent. How much can we actually allow them to claim? And our LLM would say, okay, based on this, we're gonna allow that much of allowance, right? So it's going to review the policy and provide the answer. And in parallel, we'll be computing the outcome. So here is some Python that actually manually calculates based on the policy and based on the submission what should be allowed for claim. Right. So we're building a sample of 4,000 cases. That's the train. That's for the training. And here we are looking at our prompt. So we're preparing our LLM, AI LLM to reply. So we're saying you are the travel and expense policy assistant. Use only the policy text to judge a compliance. Return strictly label equals okay, partial or reject, and amount equals to 2 decimal points, and maybe a citation. So we're asking our LLM to reply in this format. Then we're supplying policy and the claim. And obviously the answer would be followed. Right, okay, so we're doing some tokenizing here. That's a basic setup. And here overall we're performing training. So we're specifying some training parameters here. Obviously the longer we run it, the better it's going to be performing, but this is a basic model and a reasonably basic example of a use case. Obviously we're saving our model every step of the way, performing some evaluations, and obviously we're building our inference mode to be able to run it. Right, so upon running it here, we are loading the models, we're training. As you can see, that's the training loss. It starts high and then it gradually gets reduced, although not very much in the last few rounds. But let me demonstrate how it actually works. Right, where is it? So these are some of the examples here. So we have a claim, for instance, of $150 for New York, 2 days, nights free, flight hours 0, alcohol true. Right, so for instance for this one, we are having rejection because it was all alcohol, so amount allowed is 0. So that was one example. Right, let me see if I find another one. Have a good example. got one here with the amount 1321. Only half of this is reimbursed. It's also for New York. So I've got a bunch of examples here as well, additional ones to try and test this all. Couple of ones that I can show. So here we have airfare with this amount, airfare with an exceptionally high amount, but here, because it has been pre-approved, that would be okay, so all of this will be reimbursed. I was just trying to push the model to an extreme. However, this one here was not pre-approved, so it should be all denied. And this one was for the weekend, so let's see how these ones coped. So this one was rejected, the first one, because it was over the weekend. This one here was all approved. Yeah, so as you can see, we have expected and the predicted amount. So predicted is what our model predicted, and expected is what that pre-calculated function that actually works out the amount to be claimed. So yeah, because this was pre-approved, the amount is crazy and it's allowed, and the model picked it up well as well. For this one here, this was not pre-approved. False. And it was supposed to be partial, so it was supposed to be just 1,000. However, our model failed here. That's quite interesting. Not sure why. Yeah, it should have failed to say. Well, actually, it should have been partial. Yeah, sorry, it should have been partial. But it did not work for this particular case. Yeah. And as you can see, there's some foreign language here. That is purely because the model is quite basic. Only 1.5 billion parameters, and it looks like there's some confusion with the foreign language, because it should not be having a foreign language here. So that's what happens when you're using a model that's substandard. The problem with larger models, so I could have downloaded a larger model, let's say 7 to 9 billion parameters, but if I'm training it without using LoRa or Clora, fine-tuning it without LoRa and Clora would result in my memory print be exceptionally high. So yeah, I would have to resort to using LoRa Clora for fine-tuning of significantly larger model. Let me see if I can get another example here. So here is the example for airfare, 7-hour flight. Yes, so it was 2,100 claimed for 7 hours of flight. Predicted and expected seem to be okay. Yeah, but overall model is performing. Look, another discrepancy here. Partial amount. 205 was claimed. They were claiming 205. Only 200 should have been allowed. My model calculated 205. So yeah, it just hit the cap. So it was just slightly over the cap, and yeah, the cap was 200 for airfare. Well, yeah, I guess you're getting the point now. So the purpose of this exercise was to show that we can, instead of performing this function that actually digs into this huge function and tries to work out the allowance, we have calculated. Sorry, let me just quickly find this formula again. Yes, we have this function, humongous function, that does try and work out the claim. It checks all the parameters and stuff, so it's hard-coded, it's in the code. So we are doing this slightly differently. We're kind of asking our AI model to work this out with weights, with parameters, instead of using this hard-coded function. And it seems to be working in general. So that is a really good idea. So imagine if you had a tax rate that you had to apply based on different categories, on different areas, on different jurisdictions, different types of transactions. You'll be able to build this logic and feed it to your AI, a large language model, and it will be performing this for you. So just like that, pretty much the same way. Also, there's examples and use cases could be argued for accountancy, where accounting would be assigning different types of transactions, different accounting treatments, and yeah, that could potentially work, where you have to split the transaction into journals. That could be done as well. So I hope you enjoyed it. I hope it was meaningful. Please let me know in the comments if you have any other ideas on challenges that we can tackle using fine-tuning, supervised fine-tuning, or using AI. I'll be delighted to hear them. Thank you.